Hello everyone, welcome to ACE Online, and this is Narendra. And today's class, the topic is the number system. So one of the most important topic when it comes to SSC, any exams of SSC, whether SSC JE or whether SSC CGL or HCL, RRB JE, RRB NTPC, and even in banking also. So let's take some question from this chapter. So let's begin here, the very first question, and this question is a very important question, very frequently comes, very few people are able to answer the question. We will know now what is the best way to answer this question, so that if the question of this type, which is the LCM third model, comes, we will take the advantage over our competitor. Okay, so what is this? Let me go through 1 minute. Let me refresh this so that I can see you people commenting. 1 minute. Let me open in my very good evening. Thank you for joining. And let's begin here. Public better. So let's see that, Mr. Prabhu, whenever you are Pandu, whenever you are writing the RRB, any exam of RRB or SSC, the number system is one of the very important topic, and sometimes it's also important for the banking exam point of view. So let's read the question, and either you will answer the question or you will learn how to answer the question. Okay, here a number is divided by 11, leaves a remainder of 5. Fine. Now, when divided by 7, leaves the remainder of 3. What is such smallest such number? What is such smallest number? That means given to us is the number which is in the form of 11k when divided by 11. So 11k, when k is a variable, so the number is divisible by 11. But I need a remainder of 5, so 11k plus 5. And the same number when divided by 7, it should leave a remainder of 3. So we write this as 3 modulus of 7. That means, in other words, when divided by 7, it should leave a remainder of 3. Both the numbers are same. So I will give 30 seconds for you. So if you can answer the question, it's fine, or else you will learn. It's a important question for the exam point of view, and I am sure you will learn it the best way to answer this question. Come on, my dear friend. Let me see, still 30 seconds, I will wait, and after that, 30 seconds is over. 30 seconds is over. I don't see any response. Okay. It's good, even if you don't know. So this is an important question. It is not the randomly taken question. This third model of LCM is very important. So the very first writing is this step. Okay, here we have the plus 5, plus 5. So in order to make this 11k, I will go for minus 5 over here and minus 5 over here, both sides. So left hand side will be equal to right hand side. So I will be getting here the 11k, which is equal to, I will get here minus 2. So minus 2, the total is 7. Minus 2 can also be written as plus 5, reciprocal, you know. The total is 7. So either the remainder is minus 2 or the remainder is plus 5. Both are applicable. So I will write down the left side 5 modulus 7, and here it is 11. 11k. So let's write down this one as 11k, which is equal to, I take this 5 over here, that is 5, and modulus means 5 is the remainder when divided by 7. This step you are expected to know. The minus 2 when divided by 7, minus 2 is the same as plus 5. In both the cases, the number is divisible by 7. Okay. What I am going to do the next one, this 11, this 11 I can write down in the form of 4, this is 7, right? So this is how much more than 11? 4, 11 is how much more than 7? 4. So when 11 is divided by 7, the remainder will be 4. So I can write down the 11 as 4 is the remainder of modulus 7. So suppose here it is 1. So 7 into 1 is 7, and 7 plus 4, remainder this is, plus 4 is 11. Now what I will do is, I will replace this one. This is a very important model, my dear friend. I replace this one with this value, with 4. So I will be writing this as 4k, which is equal to 5. I am replacing this 11 with 4. So 4k is equal to 5 of modulus 7. The same thing I am writing this part. Then, so now you see that when divided by 7, the remainder is 5. What is the smallest such number? 7 plus 5, that is 12. 12 is such a smallest number. So what should be the value if 4k is equal to 12? Then what is k? K is equal to 3. We got the k value. Now I will go with my final solution. The number is 11k plus 5, where k is equal to 3. So 11 into 3 plus 5, that is nothing but 33 plus 5, 38. Usually people stick with the LCM model 1, model 2. Rarely the people work on the model 3 of the LCM. This is the way to answer the question in a proper way. Or else you can check with the options, but options checking will take more time in this case, because you have to check the 11 when divided by 11, the remainder is 5, and divided by 7, the remainder is 3. So you can quickly draw these 3 or 4 steps, you will get the answer. So hope you understood, all my dear friends. So here 38 is my answer, that is option choice 2. The next question, I am sure you will understand it. You can revisit this one, modulus theorem, if you know, then this everything which I wrote, I hope you properly understand. Now moving on to the next question over here is this. Look at this one, my dear friends. So it is a very simple question, and I am sure all of you who are watching will be able to answer this question. Okay, find the least number, that is LCM you are talking about, which when divided by 8, 12 and 15 leaves the same remainder, that is 4 in each case. So you know this type of question comes in the prelim. So I give 30 seconds for you, and I request all my friends who are watching, please, even though you know how to answer the question, please work out. The practice will increase your speed and accuracy. Come on, here I would like to see any one of my friend. At your end it is 19 seconds, 18 seconds. Come on, some of my friends will able to answer it. Still you have time, 10-second time is there. Try it. Here my time is over on my board. Okay. Now I will answer the question. See that this is the very basic question over here, I need to take the LCM of that number is LCM of 8, 12 and 15 and plus the remainder is needed, that is 4. That's the number. What is the LCM of 8, 12 and 15? And that is the highest power of 2 value here, it is 8 into 3 value, that is 3, 9, 27, 81 and so on and so forth. So, the here highest 3 prime number, and the next prime number is 5, only one 5 is there. The next power is 25, next is 125 and so on and so forth. This is what the LCM is. 5 8 40, 4 3 is 20. So, here I am getting 120, I need the remainder of 4, so plus 4 and the number is 124. This is the second model of LCM. Okay. Any of my friend answer the question? Any of my friend answer the question? Okay. Even if you understand it, that's great. కొద్దిగా రిలే ప్రాబ్లం అవుతుంది చూడండి సార్, అటువైపు నుంచి బాగానే ఉందా? One minute, there is a small problem in display. Alone is it? మీరు చూడండి మీ మొబైల్లో ఓపెన్ చేసి. అచ్చా, ఓకే ఫ్రెండ్స్, ఐ కెన్ సీ దట్ it's not playing in my mobile, maybe some problem in my mobile. So 124 is the answer. So where is 124? Option choice 4. Moving on to the next question, and the next question is this. Come on. The sum of two numbers is 216 and the HCF is 18, and how many such pairs are possible? The very basic question of HCF and LCM. Okay. So I will give 30 seconds over here. You may think how to answer the question, and after that it's playing. And after that, నాకు ఎందుకు అవడం లేదు సార్? The time is over. Okay, maybe there is some problem in my phone. So I am not getting display. Okay, fine, my dear friends. We know that we are talking about the sum is given to us, that is 216, and the HCF play avutunda. Okay, two such pairs. So Pandu has said that two such pairs. So let me check that the option choice 3. You are really good, Pandu. Yesterday you were very good in the topic. What was the topic yesterday? The problem on trains, I think. Here the number system also. So until unless you don't know the fundamental of LCM HCF and you have worked out all the models, you will not be able to answer this question. You know that HCF is 18. That means one number will be 18x. The other number will be 18y. 18y. And the sum of these two numbers is 216. So nicely answer the question. So when what will be x plus y? 18 is common, and 18 is common. Remove the 18 and take the x plus y. Then you are getting the x plus y is 12. where x and y are co-prime. That means x and y, there is no common factor. How many such pairs are possible where x and y is equal to 12, where these two numbers do not have any common factor? In other words, they are co-prime. So, the very first pair I notice that 1 and 11, 1 plus 11, 1 plus 11, which is 12, 1 and 11 are co-prime. Now 2 and 10, no, they are not co-prime. 3 and 9, they are not co-prime. 4 and 8, they are not co-prime. The 5 and 7, yeah, that's right. 5 plus 7, that is equal to 12, and the 5 and 7 are co-prime. So, that is what? 6 and 6, it's not possible. So, here there are two such pairs are possible. And I am sure Pandu must be knowing that this type of questions very frequently comes in exam. Okay. So, well done my dear friend, well done 1 and 11 and 5 and 7. I am moving on to the next question, and that it is this. Come on. What is given in this particular question? The product of two number is given to us. That's 2079. And we know the HCF of this. You need to find out the LCM. I am sure that this basic question you are able to answer it. Your 30 seconds starts now. Now let me see that if Pandu Babu is able to answer this question or not. Anusha, very good evening. And the Pandu has already said 77. Still he answered the question in 10 seconds. In 10 seconds. You just can understand what is the level of preparation or the practice the Pandu has. So any question I am putting, he answer the question in 10 seconds to 30 seconds. Okay, the time is over from my side. So here what we know, that the LCM into HCF, the very basic formula, which is equal to the product of two numbers. Product of two numbers. So what will be my LCM? The LCM is equal to product of two number, that is 2079, divided by HCF, which is given to us, which is 27, and I am getting over here, that's a 77. So what is the LCM of this? Is 77. Okay, I agree, basic question this is, but sometimes it's, this question comes in prelim. Well done. I am moving on to the next one. 77, that's right. That's right. Now here is that the options are left same. Okay. Anyhow, by mistake the options are left same. Shall I? But it's okay. Let's check it. You know, this type of question comes. The remainder. Find the remainder when 7 to the whole power 222 divided by 100. Come on, my dear friends. I give 30 seconds for you to think of it. If you answer the question, it is fine. Or else, I will tell you how to answer it. Okay, Prabhu, you are right. Pandu, I am sorry. Do you know how to find out the remainder? Come on. So, at your end, 10 seconds is there. From my end, time is over. Your end also time is over. Now, I'll explain you how to answer this question. So, these numbers, that is 2, 3 and 4. That's 7 and 7 and 8. When you divide any number by either 7 or 8, it's a remainder keep repeating after 4 sets. We know that part when we are learning the number system. So, what is the method over here? that 7 is there. I am talking over here. So the 222, this power should be divided by 4, because after every 4 times the remainder repeats. So here look at this one, divided by 4, divided by 4, and take the remainder, and this is applicable in case of 7, in case of 8. So here I notice that my remainder is 2. So the 7 to the power 222, whatever remainder comes, will be the same for 7 to the power 2. And what is that 7 to the power 2? And that comes 49. So what will be the remainder? The remainder will be 49, and the option is 4. Anyone answer the question? Oh, that's great. That's great. Pandu, you have rightly answered the question. You have rightly answered the question. 49. Well done. That means you have the idea of all the chapters almost, because yesterday I have seen you have done well. Here also you are able to answer the question of all the type of number system. Okay, come on, this is your next question over here. Look at this part. What is the question here? Find the largest 4-digit number. Largest. We know the largest 4-digit number is this one. So largest 4-digit number with a condition. What is that condition? Divisible by 12, 15 and 18. If previously, those who are familiar with the previous year questions, you must be knowing that in the most especially the RRB, SSC and even in banking, the question comes like this. And it's the very basic model, first model of LCM. Now take your 30 seconds and let me know your answer. Let me know your answer. My dear friends, all these days the examinations are coming. Let's work out, just practice it 1 hour. Divide your preparation, self-preparation, preparation with your friend and the YouTube classes. So try to answer the question. I am very happy that the Pandu is answering most of the question. The time is over from here. The very first thing is I need to take, in this question I need to take the LCM of what is that, 12, 15 and 18. What is the highest power of 2? Because these are the prime numbers, no? That is 2, 3, 5, 7 and so on and so forth. So what is the highest power of 2 value over here? 2 is there, 4 is there. After that, is it 16 is there anywhere? No. So this is 4. And then go to the next prime number 3. 3, then 9, then 27, then 81. So what is the highest value here? 9 is there in 18. 9 into 2. So the 9. And after that here in 15, 5 is there. So 5. So 5 for 20 into 9, that is nothing but 180. That is what is my LCM is. Now I need a largest 4-digit number. Now I already see that Pandu has answered the question and he said 9900, that means option choice 1. Let me check Pandu is correct or not. Yes, that's right. So you have a good practice, Pandu. That is what you are doing justice to yourself. So here I will go with the these 9s and divide by 118, and 18 5 is 90, that means 900. So first 5 times 900, if you take out again you are getting 999. Now 18 5, that is 90, so 99. So what I need to do, I left with the remainder 99. I need to take out 99 from 4 nines. So I will be left with 9900, and that is the largest 4-digit number which is divisible by 12, 15 and 18. Well done. Okay. The next question on your board is this. Here, Let's check that the volume of question is very simple. That is, the unit digit of 137 to the whole power 245 is x. What is the value of x? Come on. You know, in SSC you get the question, SSC RRB, you get the questions like this, and Pandu has already answered the question. Appal Naidu, very good evening, sir. Mr. Appal Naidu. So, Appal Naidu has said 7 is the answer. I am just waiting if Pandu can answer the question or not. Hope Appal Naidu you are fine. So, the time 8 seconds is there. Let the time be over, and you are saying 7, that means you are saying option is 4. Okay, the Pandu has already answered the question. He also agree with Appal Naidu. So, option 4, answer is 7. Well done, well done. So, it is very simple things what I have discussed over here. The 49 was there somewhere here, 49. So, 7. So, any power is there, so I need to divide it by 4. So, it is falling under the same condition, that is, this unit digit is 7. So, 7 to the whole power 245, I will consider this way. So, 245 I will divide it by 4, because 7 to the power anything, the unit digit repeats after every 4 sets. So, therefore, what will be the remainder of this? The remainder of this, I notice that is 1. So, 7 to the whole power 241 is the same as 7 to the power 1, and which is nothing but 7. You nicely answer the question in a very limited time. That means you understand the concept. That's good, my dear friend. I am moving on to the next question, and the next question is this. Come on, 7 is the rightly answered. Now, let me check if you are comfortable with this question. Find the smallest number which leaves a remainder of 1, 2, 3 when divided by 2, 3, 4 respectively. The second model of LCM. Yes, my dear friend, take your 30 seconds, and then we will check whether your answer is correct or not. 11. Oh my God, Appal Naidu is there. He is very dangerous competitor, and I am happy that the kind of speed and the knowledge Appal Naidu have. The Appal Naidu, the Pandu is also working with a similar pace. Is also good. Let me check. And Shiva, he is saying 11. So, 11, option 3. Let me check that option 3 is correct or not. Oh, did I made any mistake? No, not this one. By mistake, I put this. This is the right answer. It's 11. Okay. Let's check how will I answer the question. So, we have the divisors, and the divisors are 2, 3 and 4, and we have the respective remainder, that's 1, 2 and 3. So, if you take the difference, divisor minus remainder, here it is 1, here also 3 minus 2, 1, 4 minus 3, 1. So, that means I need to take the LCM of LCM of 2, 3 and 4, and from there I need to take out 1. And you know the 2, 3, 4 LCM is nothing but 12. So, 12 minus 1, that is 11. You nicely answer the question. Well done, sir. Well done. Okay, all of you, and Shiv and Jivita. Well done. Well done. I am moving on to the next question, and the next question on your board is this. Now, let's say that how many integers between 1 and 1000 are divisible by neither 3 nor 5. You know that in RRB SSC this type of question comes. Okay. Either you will answer it, so that's a practice for you. If you don't answer it, at least you will learn it. Your 30-second is here. Your 30-second is here. Let me see how many of my friends will answer the question. Please enroll the ACE online. I will tell you, we have the slides. I will show you the slides how to enroll our recorded courses for banking, SSC, RRB. Okay. So, here some of you are taking time. Okay. It will take some time. Jivita, Shiv, H good, Pandu, previous question. Pandu has answered the question, Shiv answered the question, Jivita answered the question. And 533, Appal Naidu is very dangerous. Appal Naidu is for rest of you, that is Jivita. Appal Naidu is very good. Whether you talk about reasoning, you talk about any chapter of arithmetic. When he says, oh, good, Pandu has already said 533. Both Appal Naidu and Pandu has said 533. What is option? So, option 3. Let me check that. That's right. So, within a very reasonable time you answer this question. That means you know how to answer the question. First, you are going to take the number which are divisible by 3. That means the number in the form of 3k. So, how many numbers are there? I need the quotient when 1000, this is 1 to 1000. So, 1000 divided by 3. So, how many such numbers are there? 333 numbers are there. Now, I need the number which is divisible by 5. So, that is in the form of 5k. So, what will be the quotient if 1000 is divided by 5? So, you know the quotient will be 200. So, if I directly add these two, okay, I am making a mistake over here, 533. I am very sorry, my dear friend. Will it be 533? Directly addition over here is 533. I made some mistake, I think. This is 3. So, 533 are divisible. 533 are divisible. Right. But in between, there are, okay, let me check this one. There are number which is divisible by 3 and divisible by 5 also. So, if you simply add this number, so you are repeating the number which is divisible by 5 you have already taken and divisible by 3 you have already taken. So, that is divisible by 15, that is 5 into 3. So, how many such numbers are there which are divisible by 15? So, I require the quotient when 1000 is divided by 15. So, how many times? 15 6 is 90 and 15 6 is 90. So, in these two, this 66 number is already there. So, what I need to do is that is 533 minus 66. So, I will be getting this one as 467. Okay, that's right. That means 467 numbers are there which are divisible by not divisible by 3 and 5. I need not divisible. So, therefore, the total 1000 numbers are there. From 1000, if I take out 467, you people have rightly said 533. Well done. Well done. All my friends who have said 533, Appal Naidu, the first person to answer the question. Siva, 533, you are right. Pandu, you are right. Now, let me move on to the next question. And the next question on your board is this. Here is the question. What is the question? The sum of the digits of a 3-digit number. Sum of the digits of 3-digit number is 18. Okay. Now, if the number is divisible by 9, you know, if the sum of the digits are divisible by 9, the number is divisible by 9. if the number is divisible by 9, find the smallest such number. Yes, friends. So, you may answer the question, may not be able to answer the question. If you answer the question, it's a practice. If you don't answer the question, it's a learning. Oh my God, Appal Naidu is very dangerous, and Rakesh is there. He is also very, very dangerous. Mr. Rakesh, these people are dangerous competitor. Appal Naidu is really very dangerous competitor, and it's good for you. I am very happy, and so is Rakesh. I don't know you know each other or not. Okay, 30 seconds is over, and as you said that your answer is 189, let me check that 189 option choice 3, you are right. Well done. So, what you have done over here, let me see this part. Either you might have gone for the divisibility rule of 9 because the number is divisible by 9. So, here it's 9 divisible by 9. I can see this number divisible by 9. I can see none of these is there. So, I may not be able to go with the option. So, what is the possible thing? I need the smallest such number. So, my 100th digit x, y, z. So, here the 100th digit x, let us consider that this is 1. And sum of the digits, sum of the 3-digit number is 18. So, what should be y plus z? Y plus z should be 18 minus 1, that is 17. So, that x plus y plus z is 18. So, what could be the value of I should take to make it 17, 2 digits x and y. So, here 8 and 9 is the only possible number. So, here I will be taking 8 and 9. Now, as I need the smallest number, so instead of taking 98, I will be taking 89. So, the whole number will be 189. That's beautifully answered the question, and you can see that the number is also divisible by 9. Well done. Well done. So, Pandu 189, Rakesh is there, Shiv, I think you are understanding, Jivita, hope you are understanding it. Now, moving on to the next question, and you know that this type of question comes in the examination. So, what is this question? Allow me to read it out. 3 bells are there, are ring together for first time at exactly 8 a.m. The first bell rings after every 36 minutes. The second bell rings after every 48 minutes. And the third bell rings after every 1 hour 12 minutes. Now, at what time will they all ring together again for the first time after 12 noon? If it is said first time, if they stop over here, we know how to answer the question. But it says that first time after 12 noon, a small condition is placed. So, take the 30. Here, I understand that, no, you people are so smart, I don't need to give any hints. Take your 30 seconds. And let me see that Vijita can answer the question now. Shiv can answer the question now. There's a together practice. Huh? So you will learn. You don't know what question I am going to give. So you will learn a lot. Or as you are answering the question, it's a practice for you. For example, Prabhu has already answered the question. He says option 3, that is 112. And Appal Naidu has said 224. 224. And Pandu has said 1248. All three of you have answered differently. So, let see Shiva. and also Jivita, who is right here. So 12:48, and Pandu has rightly answered the question. Well done. Now we will see how should I answer the question. So if it is not there, 12 noon is not there. So what I am going to take, I am going to take the LCM. I am going to take the LCM of all these three timings. The first is 36, the second is 48, and the third one is 60 minutes plus 12 minutes, that is 72 minutes. So what will be its LCM? What is the highest power of 2? So 2, 4, 8, 16, 32. I notice that 16 is there. 16 3 is 48. So 16 into the next prime number is 3. So 3, 9, 27. So here 9 is there. 9 into 8 is 27. And the next prime number is 5. Anywhere 5 is there? No. Next prime number is 7. Anywhere 7 is there? No. So 16 into 9, that comes 144. And the 144 is 120 plus 24. That means after every 2 hours, 24 minutes, they build together. So here it is 8 a.m. it is given to us. To 8 a.m. if I add 2 hours 24 minutes, that comes 10:24. But it is said that first time after 12 noon. So if I go for the one more time, then this is 4 hours 48 minutes. So if I add 4 hours, so 8 plus 4 is 12. So after 12, 48 minutes is there. So plus 4 hours and 48 minutes. Finally, I get that as 12:48 p.m. is the time when the bell will first time bell together after 12 noon. Okay, okay. Is that clear? Appal Naidu, 144. Yeah, LCM is 144. Hope all of you who are watching this question is clear for you. Right, my dear friends? Okay, well done, well done. And moving on to the next question over here is this. You know the recurring decimal based question comes. So allow me to read it out. What is the question here? It says that convert the recurring decimal to 0.13472. The bar is on 472 into a fraction in the simplest form. And you have these options. And you know conversion from recurring decimal to fraction is one part of number system. So take your 30 seconds, my dear friend, and answer the question. And answer the question. Let me see that how many of you can answer the question. 2 things. If you answer it, it's your practice. If you don't answer it, you will learn it. Rakesh is danger. Option A. Pandu, you knows the method. It's good that in the number system, you are very good in the number system. You have gone through all the type of models, the divisibility rules, right from the divisibility rules and the LCM, HCF based question and the recurring decimal, successive division and all and all. So Pandu has said that 21, 35, 9. 21, 35, 9. We don't have the options. You are missing any number. Option A, Pandu has said, Appal Nadu has said, Rakesh has said. Let me check that. That's right. Option A. Okay. How we answer this question? You know that we write the whole entire number 2, 1, 21, 34, 72. 34, 72 minus the number without the bar. So what is the number without the bar? The number without the bar is the entire number is this 213. So we subtract this 213 from here, and so we put the 9s in denominator. How many 9s? Under the bar, whatever the under the bar, the number of digits should be equal to number of 9s here. So there are 3 digits are there under the bar. Therefore, there will be 3 9s over here, 3 9s, and decimal part without the bar. This is the decimal part without the bar. That is 2 digits are there. Therefore, here I should place a 2 0 here, 2 0. That's your answer. So let me check that what comes over here. That is 9. Here it is 12, 9, and 6, 1, that is 5, and 4, that's 2, and 213 will remain same, 213, 259, 213, 259 by 99900. Option 1, that's right. So how many of you answer the question here? So whoever has said option 1, that's right. Okay. So under the instructions, I need to share the course which we are offering to you. Now look at this part, my dear friend. Don't get bored over here. IBBS clerk prelim, all the recorded courses there. So 3 months, 6 months, 7 months. So 1500 is the fees, but if you are applying this code is 50, you will be getting the 50% discount. With only 750, you will be able to get the entire course for the RBA, IBBS clerk prelim, and SBI clerk prelim, and also IBBS RRB clerk prelim, and plus we are also offering the SSC JE and RRB JE, SSC CGL, RRB CGL, and also banking courses as I detailed it. So today actually the class was scheduled for only half an hour, but still it's 50 minutes I have taken it. So today I have to conclude it over here, and hope you will not get disappointed that less number of questions are discussed. The next class I will discuss more and more number of questions. With this, wish you very happy Independence Day to all of you. Thank you very much.